Recording has started. Okay, then a hello to our audience and welcome to our talk on the user retention on Wikidata and looking if the so-called Lindy Effect applies. You will later get explained what that Lindy Effect is. We will cover that. And Goran did the data analysis for that. I will introduce you sort of how we got to the point that we wanted to look at that. And we also got a lot of support from Martin Gerlach, who helped us quite a lot in interpreting the data, as well as I think Adam White also contributed some of the possible interpretations. There is a Fabricator ticket that we will later link, where you can very transparently sort of track our progress there. But let's get started how we got to that topic. So we did a community survey in early 2021 with the intent of, similar to, for example, what GitHub does, seeing like how's our community composed, sort of what are some basic demographic statistics, also what are their motivations and so on. And one key data point we asked for, since when people are with us in that community, since when have they been active on Wikidata? And later when we analyzed the data, we got this pattern here, which you see as a bar chart. So there were quite many users from 2020, and sort of it then went lower for the last 3 years. So if you as a UX or product person see such a nice graph, you might sort of think of, oh wow, like that's exponentially scaling. Very interesting, looks good for us. And indeed, our community is growing, but also it's that exponential that it's very obvious that there must be sort of a flaw with that sort of intuitive interpretation. And obviously, we measured at a specific point, so we rather need to interpret that backwards. So it's not about sort of projecting in the future immediately from the graph, but actually looking about the history of the users and also about why people keep sticking around, how they stick around. And this is the point where this becomes very interesting for Wikidata. Most of our listeners will be familiar with the term community health and the growth of the Wikidata community. And everybody who is active as an editor will know about the difficulties of actually maintaining a good data quality. And obviously for that, it's interesting getting new contributors who support us in maintaining data quality and keeping experienced contributors around. And then the questions are very obvious, like how is sort of our account age distributed and for how long stick editors around with us? And these are the basic questions we want to look at, with the effect of looking also how can we retain editors that are with us since quite a time, and how do we retain newcomers that join us and help them to be a substantial part of the community, maintain the data quality. And also particularly interesting then, if we look at the data we have now, can we sort of project the trajectory in the future? Similar to sort of my first intuition where I showed the slide of the exponential growth, like how can we actually realistically project in the future how that might actually look then. And there's already quite some research on Wikipedia and editor retention there, but there was very few on Wikidata, and that is so sort of where we thought we could thread new ground here. So one thing that came into my mind when I saw that graph and thought a bit about the interpretation is the so-called Lindy Effect, also called Lindy's Law, which is very simplified, saying that the longer sort of something exists, the longer it's likely to stick around, with a specific formula though, which you see here, that there's a proportional relation between the retention time until now and some factor. And this is what we also checked, like, does that Lindy effect apply, or is there some other relation there? So this analysis is now what Goran will take you through. This was my introductory part to that. Goran, you can now take over.
Thank you, Jan. I just think you need to hand over the controls to me. Thank you so much. Okay, so let's check if this works. It does. Okay, so as Jan explained, we started looking for the Lindy effect in the phenomenon of Wikidata user retention, described by this simple relationship here, telling us exactly that the retention time for a user from now on will be somehow proportional by multiplication with the retention time until now, the retention time that was observed until the moment of the observation, right? There's a very specific relationship. So we started looking for all the data that we actually had. We used the Foundation's data lake, where we have this huge denormalized history of all the user revisions in the so-called MediaWiki history table. That one is also available from the dumps, by the way. So whoever wants to replicate the analysis will find the links to the dumps there, and also the full R code that we use to perform the statistical analysis and the modeling. So essentially, we first grabbed the user revision histories. I will explain exactly what I mean by user revision history for almost 400,000 users, essentially everyone who ever registered Wikidata, and given that the accounts are still alive, in a sense, not of editing, but being in our databases at all, that they were not ever deleted, right? So each user revision history is on a monthly resolution. That means we look at each successive month, okay? And we mark months as active and inactive. So if a particular Wikidata editor made more or equal to 5 edits in a month, say in January 2021, then we say that was an active month for that editor, right? And if in the next month, say February 2021, they made less than 5 edits, we call that an inactive month. There is a criterion. That criterion is pretty ad hoc. I mean, we had to choose something, and then we choose these 5 edits as a line where we actually decide whether editor was active in that month or not. Of course, from all the data sets, so you can imagine that we have tons of inactive users, so quite expectedly, so we deleted all long tails of inactive months. So if we observe 5 inactive months, we automatically say that user has left Wikidata, given, of course, that they did not reactivate, because some users also spend some time not editing Wikidata and then reactivate again. We kept those data, right? We counted the numbers of the reactivations, and also we counted how many active months were present in each user's revision history, given the full length of the revision history. That is the account age since the registration until the time of observation, okay? Also, we added some additional features there, some additional information on editing behavior. I will explain that a bit later. So the first important thing is that when you look at the population, we are actually looking at the population of Wikidata users here, editors, if you prefer. So the chances of leaving are really high. So only 8% of this 400K users who were registered, whose revision histories we fetched from the database, were active at the point of the analysis, which means that the probability of leaving is 9.92, which is quite high, and this is really not unexpected. To the contrary, I would be surprised if we find any lower number than that. So I will show you now something which is really important, and that is, we need to understand this relationship. This is in relation to the Lindy effect, and not quite a formulation of the effect in itself, because that effect is mathematically very, very specific. It has a very precise definition. So here on the horizontal axis, you have the number of total active months per user account. Once again, the number of total active months. So we take a look at the user revision history. We find that somebody registered in Wikidata, say 100 months ago, right, or 50 months ago. And then we count in how many months did that user made more than 5 edits or 5 edits exactly. And we simply count the number of active months, right? And then we grouped all people which actually had the same number of active months, And we put that on the x-axis, and on the vertical axis is the probability. We simply count how many, the probability to leave Wikidata. We counted how many people from each group have left Wikidata. You can see there is a clear and regular relationship, right, between the number of active months, which is a proxy measure for the user activity, right, and the probability to leave Wikidata. Obviously, those who frequently edit have a way lower probability to leave Wikidata and stop editing in comparison to those who edit rarely. Okay, now this chart can be confusing because there is a slight confusion. One could say, well, of course, because if you have a longer account age, right, and older accounts, they also have a higher probability to have a larger amount of active months. Okay, so in order to account for that, in this chart, you can see on the x-axis, the horizontal axis, this is the probability of an active month in a user's revision history. That is simply, you take the whole revision history, and now that's a sequence of zeros and ones, right, recoded. 0 is an inactive month, 1 is an active month. We simply count how many active months were in a given user revision history, and we divide that by the account age, by the length of the history, okay? So what you get is a proportion, which is exactly probability, and we can see here that there is, again, a regular relationship between the probability of being active in a given month and the probability to leave Wikidata. People who are more active simply have higher chances to be still with us, still contributing to Wikidata. Once again, this is not still the exact dissection of the Lindy effect, okay, which takes place now. So how does one test for the Lindy effect? Well, it shows that the Lindy effect has simple and yet deep mathematical connections to something else, which is called the power law distribution, or the Pareto distribution. I'm sure that even if you're not in statistics, you have heard about the famous 80-20 rules and the highly skewed J-shaped distribution, which describe tons of inequality phenomena in social sciences. For example, the distribution of wealth. It's not only doesn't always take a mathematical form of the Pareto distribution. There are other related probability distributions there, but it was showed that if the Lindy scaling holds, as Jan explained, which means that the remaining retention time, the lifetime expectancy of an account, if you like, is strictly proportional to the time since the registration, the time that the user is already with us, right? So if that holds, it turns out that the account age has to follow the so-called Pareto distribution. So it has to be the so-called power law. So that means that testing, if we observe the Lindy effect here, is equivalent to testing if the account ages are actually distributed as power laws, right, as Paretos. So this plot here, this is something which is historically was before the development of some more advanced mathematical procedures. This was used almost exclusively to figure out if something is a power law or not. So in this chart, so we first take all the account ages from all 400,000 users, okay, Wikidata users. And then we take a look at how frequently do particular values of account ages in months appear, right? So say 25 persons has an account age of 85 months, okay? That is the frequency of 85 months, right? It's 25, so many users. That's called frequency. We plot that on the vertical axis, and the x-axis, the horizontal axis here, that is simply the rank of frequency. Okay, so we take the most frequent account and give it a rank of 1. The second one has a rank 2, etc. What can be shown mathematically is that when you plot rank against frequency in this way on the logarithmic axis, in the logarithmic space, the power law holds if that relationship is linear. And that's the reason why a linear fit is present in this plot. Okay. So you can see some deviations here at very high frequencies, right? And also some deviations there. So once again, this is just an illustration. It's not really telling whether we are observing a power law or not. In order to do that, you actually have to do some hypothesis testing. And just recently, in the previous 10 or 15 years, efficient methods to have a maximum likelihood estimation of power laws were developed. We use the power law package from the programming language R, of course, which we typically use in Wikidata Analytics and Wikimedia Deutschland. and use two very, not really similar, but quite different methods indeed, but two different approaches to test whether the account ages follow the Pareto distribution, whether they are distributed as a power law. Here, what you can see are the so-called distribution parameters. We don't really have to get into all the details here. At first sight, it looks like it is a power law, but then after some numerical simulations to confirm that, we figured out that there are almost zero chances that this is that the account age in Wikidata is distributed as a power law. Then in the next step, we asked, wait, if the account age is not a power law, what about the total number of active months? Okay, so this is now not strictly about time anymore. We just look at the number the number of active months in each user revision history, right? It's a proxy measure of activity, right? How people were active in the past. So now it is like reformulating Lindy Effect to ask, so if person A contributed X in the past, does that mean that we can find some multiplier which will tell us how much activity we will expect from that person in the future, right? So we tested Lindy there, and once again, on the first site, it looked like it could be a power law, except for these anomalies here at the tail. But then again, statistical test shows us that they're simply, I apologize, that simply we cannot talk about power law in this case either, right? So what's the conclusion here? The conclusion is that definitely not. Okay, so it's not a Lindy effect. That does not mean that people who are editing since a long time are not less likely to leave, or that the newcomers do not have the highest probability to drop out. They do. Those are empirical facts, right? It simply means that this simple scaling, proportional scaling, which is implied by the Lindy effect, does not hold, right? So in the next step, we asked a simple question and then used the even more complex mathematical machinery to try to answer it. So can we predict from the data that we have if a user will stay or leave? I will not go into details here. We used something, it's simply a binary classification task. So we look at the user revision history and some additional information called features in machine learning. This is the list of all the variables that we use to try to predict if a user will stay or leave in a binary classification task, right? So the user will in the end leave or not. We look at the data and try to use these features combined in a very complex algorithm called XGBoost for so-called gradient boosted trees. Train the model in not quite an elaborated procedure. We simply want to take a look at the first results, and the first results were quite satisfying. So what we were able to observe is that even using this simplified machine learning setting, we observed the result which is a bit better than the best model of Wikidata user retention that is now present in the literature, except for the fact that they use a different definition of user retention than we do. So it's questionable, are this model really comparable? And if you remember, probably the most important finding is that if you remember in the beginning, I explained that there is 0.92 probability that somebody will leave Wikidata. That's a population number, of course. When you take a look at all the users who ever registered with us, and if you take that as your so-called a priori probability and use the very, very simple mathematics, including the Bayesian theorem probability, we figured out that starting from this 0.92, if our model says that a given person will leave Wikidata in the next month, right, then that means that they will leave with a probability of 0.99, okay? So without getting into all the complicated results of this procedure, we simply show that it is essentially, that was most important to us, to show that it is possible to predict user retention or whether the user will stay with us or leave, in spite of the fact that the simplification that could be used if Lindy hold was not available to us. So all the code is, of course, public. There's a GitHub repository. I even shared there the data sets, the raw data sets that we use to produce all the analytics, the visualizations, train the model, test the Lindy effect, or if you like, test the power law. Also, you can always replicate from the dumps because as I told you, the Wikimedia history table is available from the Foundation's analytics dataset page, where you will find access to their dumps. We did something else. In this first script, we actually used HiveQL to access this data in the big data storage Hadoop, because we're really talking about tons of data. So you can go there and pick up all the resources that are present here, take a look at the code, there are context there. So if you need to know how we did it or what we plan to do next with it, you can ask us. And that would be it. So if you have any questions in relation to this, let us know.
Yeah, I think we have, we have one question here, which is how many editors have a perfect record, which means sort of how many have sort of started editing and never dropped out. I already said that I think we have not looked at that specifically, but that you, Goran, might have some more clear ideas on that rather than I. Do you know about it?
Thank you. Well, I don't have the precise numbers on descriptive statistics now with me, but I encourage anyone who is interested in the precise numbers from this quite representative data set, I would say, just get in touch on any channel with me, and I will provide the numbers in a flick of an eye. So just not right now, because I will have to start the R session again on a server and load the data sets. That will take some time. But all the numbers that you asked for, I'm now looking at the public chat. It was not open while I was presenting, so I didn't see the questions. So all the numbers that you're asking for, I can give you those numbers.
Then another question is, what is the takeaway from our findings? Is it that we should strive to offer new users monthly activities for them to hone their skills? And I think for that, I must say that would be a product decision, and we have not discussed sort of possible follow-up actions here. We didn't look that much at this streak component, though many people are obviously familiar with that from apps like Duolingo, for example. Our primarily interest was first and foremost descriptive here, and also it could guide in the future, like where are particular points where we might actually want to support users, especially to prevent them leaving the project. We have not specific product ideas yet on what we would do there to prevent drop-off. It's basically like looking at it and finding it out, sort of where it happens. And yeah, anything further needs to discuss with our product management.
Yes, and there is also an additional thing, and that is we have now used a very, very strong mathematical model, but more important than that, tons of information, right, and a very rich data set. The questions related to new editors, in the future, we would have to pose them in a completely different mathematical framework, right? Why? Because a new editor is not a person for which we observe, say, 50 or 60 months and then count how many times they were active, right? So this works only on the population scale, only on these huge numbers that we've obtained now in order to test whether the phenomenon is predictable at all or not. It looks like it is. But the approach to the new editors question should, it definitely needs to be different. I'm not even sure if machine learning would be helping there. I would stick to say, organizing what we already do, by the way, in Wikipedia, at least, like organizing workshops and the community help and support. That would work better for the retention of new editors, and asking a question for the machine learning perspective with somebody who is with us for 5 months. Stay with us in the next month is first difficult, and second, I'm not sure whether it pays off to go into a study like that.
As was Goran answered that already on the chat, but I think it might be interesting for those who are not following the chat. Is this analysis also done possible or easy to do for Wikipedia? To which Goran already answered. The same analysis could be done for Wikipedia or any other of our wiki projects. And as far as I'm concerned, it actually has been done. There are user retention studies for Wikipedia, obviously not with exactly the same framework we were using here, but there are quite some papers, and I guess quite some of them are also linked in the Fabricator thread, where Goran, me, Martin, and Adam shared sort of some readings. So people interested in Wikipedia or any other wiki project there and similar analysis will find some reading there.